Welcome to Chapter 7 video lesson. We're dealing with a 90% confidence interval when the population standard deviation is known, which that's sigma known. So depending on how they write it in the problem, they'll either say sigma equals or they'll say population standard deviation. So let's look at an example here. We want in this particular problem, 28 employees were sampled, and the mean that they traveled was 14.3 miles. Population standard deviation is 2 miles, and we are to find a 90% confidence interval for the true mean. First thing to look at here is that the population standard deviation is what's known. Population standard deviation. And since it's population standard deviation, that means sigma known we use z-scores, just like you did in Chapter 6 with normal probability. So we're going to have to find the z-scores when that time comes about. We are looking at a sample of size 28. We know that our x-bar, our point estimate, is 14.3. We know that our standard deviation is 2. So what we need to know now is the z-score. So for a 90% confidence interval, that's alpha equals 0.10 or z alpha over 2. Okay, the alpha over 2 would be 0.05. So let's go look at that. What we need to do is go to our normal table, normal probability, and what we're going to need to do is find that 95% in here in the middle of your table. In this case, right there. Our 95 is right in the middle here, in between our 95.5 and our 94.95. So when you think of the probability piece, you've got a 9495, which matches with a z-score of 1.64. We want the 9500. Well, it's bounded on the other side by a 9505, which matches with a 1.65. You can see that by looking over here, the 1.6, the 1.64, and the 1.65. So that's matching up those, and we're right there in the middle. Since we're in the middle, we have to use, in this case, 1.645 because it's exact middle. We typically use the closest. Just like when you were doing percentiles. Often you're told to use a 1.65 instead of the 1.645. I like the 1.645 for a reason that I'm going to show you now. If you look now at the table, F table, it's the t distribution table. Notice there's a 90% confidence interval. Now if we scroll all the way down that column, you'll notice that the z, corresponding z here, is 1.645. So that's for a 90% confidence interval. Likewise, over here is the 80% confidence interval, a 95% confidence interval, 98% confidence interval, and the 99% confidence interval. So when you're dealing with these special ones, I suggest you come here. I think it's easier than jumping back and forth on those in the Z table. These are ones that are normally used, so they're quick and easy to find there. So back to our problem. Z alpha over 2 was 1.645. Now we're going to set up in our formula our point estimate minus Z alpha over 2 times sigma over square root of n to x bar plus Z alpha over 2 times sigma over the square root of n. Now it's a matter of substituting in the values. X bar, we already noted, 14.3 minus our Z alpha over 2, which is 1.645. Sigma, we noted, was 2. N, for square root of n, 28. And then 14.3 plus our Z alpha over 2 times sigma, which was 2, over our square root of n, which is 28. So there's everything substituted in. When you get ready and you actually calculate those values, you will come up with 13.68 to 14.92. And that's the confidence interval. What it's trying to tell you is, in our normal curve here, with our 14.3 being the center of our confidence interval, well, over here on the ends are 13.68 and 14.92. A pretty good guess, 90%, that your actual mean is in that region. This is where we think mu is. A 90% confidence where the mean is. So that's the setup for this. When I'm grading this, the things that I am going to be checking on are that you are using z-scores when you do. You are noting your n. Definitely that you're finding the right z-score. Okay, you won't have to necessarily be doing the z alpha over 2 look, because you can look that up on the table. Definitely showing my formula. Definitely showing the substitution. Definitely ending up with a confidence interval. Portion down there over in the corner was just a small explanation. So that's an idea of what you're going to be needing, what you're going to be showing. If you have questions, obviously, email me or call me.